Ho, 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 Algebra 2. Alright, it's time for Module 3 in Unit 9, Lesson 2, the what power. Here we go. Alright, it says to evaluate each expression. The first two have already been completed to you. So the what power basically says this. 2 to the what power gives me 8. So the answer turns out to be 3 because 2 to the third power. Okay, and 3 to the what power gives me 9. Well, 3 what squared gives me 9, so your answer is 2. So let's give some of these a try here. So 6 to what power, I call it x, gives me 36. Worst case, we go back to like the last lesson here. And we say, okay, 6 to the x equals, how do I do 36? Well, that's 6 squared. So my answer is x is the 2. Remember, just get the bases the same. Set the exponents equal. So the answer is 2 on this one. 2 to what power is 32? Maybe you know that. 2 times 2 is 4, times 2 is 8, times 2, etc. You will get an answer of 5. 5 sets of 2s multiply to that. 10 to what power? So 10 to what power equals 1,000? That's what they're asking here. Well, it's 10 times 10 times 10. You need 3 tens. 10 to what power gives me, what do we got here? 1 million. Well, last time you took a look at it, there were 3 zeros to make 10. So for 10 here, I got 6 zeros. So guess what the answer is? 6 is a little shortcut. Now watch out on the next one. 100 to what power equals a million? Well, it's pairs of zeros. So I got 1 pair of zeros, 2 pair of zeros, 3 pair of zeros. So guess what? It's going to be the third power. If you do 100 third power on your calculator, 100 caret 3, you will get that. What power of 4 gets me to 64? We did that a lot in one of the last chapters. You know that 4 to the third power, 4 times 4 times 4, gives me 64. So that's the introduction to the what power. Alright, as we continue this, 2 to what power equals 64? And yes, you can write 64 as 2 to the 4th, 2 to the 6th power, so my answer is 6. 9 to what power equals 3? Well, we just made it smaller, folks, didn't we? So what do I have to do? I can't be going bigger than 1. It's got to be smaller than 1, so somewhere between 0 and 1. But I'm not making it a reciprocal, so it's not going to be negative, is it? It's going to be between 0 and 1. You should recognize it then. It is this thing here. Take 9 and we go 1/2. So 9 to the 1/2 power, which means I take the square root of 9, right, is 9 to the 1/2. Same thing as square root of 9, which is 3. So that's 1/2. 5 to what power gives me the square root of 5? Well, remember, you can rewrite that as, cross that out and call that 5 to the 1/2. So there's your answer again. 1/2. 1/2 to what power gives me 1/8? Well, all you're doing is, okay, what times 1 gives me 1? It doesn't matter. And what times 2 gives me 8? Or not times 2, but how many 2's make 8? Well, it's 3. So if I cube the whole thing, 1 times 1 times 1 is 1, and 2 times 2 times 2 is 8. Okay? What gives me 42? 42 to what power gives me 1? We saw this in the last lesson, and we know that that basically means 42 to the 0 power. Anything to 0 power is 1, so your answer is 0. Then 100 goes into 0.01. Well, you guys got to recognize 0.01 is 1/100th. So 100 to what power is the same thing as 1 over 100. That's what 0.01 is. So how do I get the reciprocal of that? Now that one introduces the negative concept we're talking about. So that's just a reciprocal, -1. 2 to what power equals 1/4? Well, there's the reciprocal again, right? The 2 is going to go in the bottom, so this is really 1 over 2 squared. So guess what your answer is? -2. If I do 2 to the -2, I got to put the 2 in the bottom, and then I got to square it. All right? That finishes this section up, and we're really ready to roll. Oops, I guess I lied. 1/4 to what power is 2? So 1/4 to what power, that's the whole thing, equals 2. Well, obviously the 4 has to come up top, so that's the negative. And then how do I go from 4 to 2? Well, I have to take the square root of it, right? which is the half power. So its thing is a little tricky. Negative 1/2 here. We'll do it. Don't believe me? Take 1 divided by 4 in parentheses, raise it to negative 1/2 power. You will get 2. I want you guys to talk about this one and see if you can come up with a rule. We can talk about it in class, okay? So now we got some exercise to practice with this a little bit. It says, how about some real numbers like this? What power of base 7 gives me 49? So 7 to what power equals 49? We're doing the same thing. You're saying 7 to what power equals 7 squared, because that's what 49 is. So your answer, 2, because you can set the exponents equal each other. So there's my answer. Okay, 0 to what power gives me 7? Is there any way you can ever change 0 and get 0 to some power and it's going to change anything but 0? No. So this has no solution on this one. And we're going to see a bunch of these here and there. Here's the case. There's no 0 to whatever power. You can make it 100, you can make it a tenth, you can make it whatever. You're not going to get a solution. So go to number 3. 5 to what power is equal to 1? Well, we already said that. Anything to the 0 power. So x is 0. That's your answer on this one. Last one I said was no solution. Okay, next screen. Okay, on this one, number 4. 1 to what power gives me 5? Is there anything I can multiply so many times 1 to get a 5? No. Your answer, no solution again. Negative 2 to what power is equal to 16? Now you might say, oh, there's nothing I can do times negative 2 to get there, but yes, there is. If you actually rewrite this to negative 2, and I know it's a negative 2, but if I do negative 2 to the 4th power, negative 2 times negative 2 is positive 4. Times negative 2 is negative 8, and then times another negative 2 is positive 16. It works, so your answer, 4 on that one. This one, negative 2 to what power equals 32? Well, if I do a negative 2 times negative 2, that gives me 4. We just did this and got 16. But what's 16 times another negative 2? It's negative 32. There's no way you can sit there and try all day. No way this is going to happen. So there's another no solution. Okay. 1/3 to what power equals 9? All right. Well, how do I get that? Well, if I rewrite the 9, I've got 1/3 to what power equals, how do I rewrite the 9? Well, if I have a negative 1, it comes 1/9, right? And I want to take the square root of 9. So if I actually do this, it's 1/3 rewritten negative 2nd power. So that's my answer. 9 to the, or 1/3 to the negative 2nd power. The negative will flip it so the 3 comes up top, and then I square it to get a 9. Okay. Number 8. We got a 1/3 to what power equals 27? Okay, well, first of all, I got to flip it, right? And if I flip it, that's a negative. But a negative exponent times another negative, so you're thinking, oh, it's negative 3. Well, negative 3 times negative 3 is positive 9, times negative 3 is negative 27. Once again, you can try all day, but there is no solution on that one either. Okay, so once again, I want you to describe what the situation is, and we will discuss that in class. And then they give you a little graphic organizer here on what characteristics, because this is basically telling you where we're going for it. What are we calling the what power function is known in the math terms here as logarithm that I've been talking about coming up. So these are logs. So that's the official name of a logarithm here. So it's our center vocabulary word. We've got examples like we just did that work. We've got examples that don't work. We got characteristics here that you're supposed to come up with in those 2 pieces. And we got definitions over here. So take a look at those things and just be ready for that part in class as well for some discussion. Now we're going to practice some more. Okay, so I'm going to check to make sure you tried these. These are ones we already did. A lot of them are actually almost the same or just tweaked a little bit. So you must do. You do, and I will check in class this page, okay? So I'm hoping you're listening to this. Got one more set to look at. Alright, so the log of 2 to the base 2 of 32. It's really still, once again, the what power, but now we officially have our logs in it, just like we did in the last part here. So really, you set that equal to x is what you're looking for. So I take this base as my base, so that's 2, raised to the x on the other side has to equal 32. And it really comes down to the what power again. So 2 to what power equals 32, and we know that 32 is 2 to the 5th power, so your answer is 5 there. 3, set it equal to x to the what power of x. Sorry, 3 to what power x. Well, you can set the whole thing equal to x, but 3 to x equals 81. Once again, 81 is 3. You can rewrite it as 3 to the 4th power. So my answer is 4 here is what we're coming down to, okay? Can't write this whole thing this way. I don't want to do it that way, but that's what you got. 9 to what power equals 81? Well, how do you get from 9 to 81? You square it, of course. All right. I'm going to skip this one and let you try D on that. Let's go take one of these out. Here's the log of 1,000. So there's 3 zeros. I talked about this before. There's a set of 3 zeros. There's a set of 3 zeros. There's a set of 3 zeros. So we have 1,000 to the x, because it's technically set and equal to x, and you're solving. So what is that equal to? It's equal to this whole, is it not even a million this time, is it a billion? So your answer turns out to be 3. So that's equal to that thing, we're setting 3. Alright, I want you to finish these off, as well as the final page. So finish these for class. And I want you to try these in class as well. Alright, so give these a try. So you have been introduced as a summary to the what power, also known as the key word, logarithm. So give all these a try. And I will see you in class.